Hello students, how are you? I am fine. My name is Vidisha Paul. Today I am going to teach you tetravalency property of carbon. That is the basic property for carbon that you need to know. Because of the structures of carbon depends upon this tetravalency. If you understand this tetravalency property of carbon, then you can easily write the structure and hydrocarbons you can easily write. So let us start my class today with tetravalency of carbon. So carbon, you know what is the atomic number of carbon? It is 6. Okay. So let me write here 6. 6 represents atomic number and it is for carbon. Okay. So what is the electronic configuration for carbon now? 1s2, twice s2, 2p2. So the total number of valence electron in carbon is 4. How 4? Because we know the number of electron present in the outermost shell of an atom is called the valency of that element. So for this carbon, the outer shell is 2, isn't it? So how much electron present in the 2 shell? That is 2 plus 2 equal to 4. So there are 4 valence electron for carbon. So these valence electrons makes available for bonding with the other elements or atoms. So for carbon it is 4. So carbon we can write here Lewis dot structure 4. These are the valence electrons which are available for bonding with other atom. So with this electron it can form 4 bond with some other atom. So the 4 bond forming tendency of carbon is known as tetravalency of carbon. That's it. So what you need to remember, carbon has 4 hands. Okay, if you remember this, you can easily draw different structure and very complex structure you can write it very easily. Let me clean the board now. Let me draw some structures. So in your different books you can get this type of structure for carbon. So in order to know where the carbon is present, you need to draw this. You need to know that where carbon should be present in this structure. For this, you should remember that all the corner positions and side positions carbon should be present. So in this case, the carbons are present. Let me use some other color pen. So this is carbon, 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 and this is carbon. So I have already explained you that carbon should have 4 hands, isn't it? So you see in this structure, this carbon has how much hand? Only 1 hand, isn't it? So for clarification, let me write here that carbon should present 4 hands, but in this carbon it has only 1 hand. So we need to give here 3 hands. So I am considering in this case the bonding has been taken with hydrogen. So okay, you can take some other atom also. First I have written here hydrogen because hydrogen has only 1 valence electron. So that valence electron it bonds with other carbon atom to form this hydrogen and carbon bond. So no need to go to so much complexity. You just consider now that this carbon should have 4 bond. Okay. So this 4 bond of carbon I have shown here, and the rest, this next I am going to show you. This carbon has 2 hands, isn't it? This carbon has 2 hands. So how many hands are required? 2, because 2 already it is present. 2 more, it should be written as like this. Okay. So similarly, this carbon you see, this carbon also has 2 hands. So it should also have 2 more hands. Similarly, this carbon has 2 hands. So you can write it like this. This carbon as well, 2 hand, like this. This carbon also has 2 hand, 2 more is required. This carbon, it has only 1 hand, like this carbon. So it will have 3 hand. So this structure is completed. From that your previous structure, what I have given you, this structure, from this structure, now you can easily say that this is a simple hydrocarbon. Hydrocarbon means carbon and hydrogen is present. So this structure is complete now, isn't it? So this structure represents actually this structure. Okay. So got my point? Let me consider some other complex structure for you in the board at first. So let me check with this structure. Okay. So in this structure again you consider all the carbons in all the corner position. These are the corner positions. I have taken here the carbons. Okay. Now you see this carbon, it has only 1 hand. No matter what is the structure may be, you should concentrate that carbon should have 4 hand. Okay. So in this case carbon has only 1 hand. So sorry, in this case this is also a corner. This is also corner, so we need to write here 1 carbon as well. So in this case this has how many hand? Only 1 hand, so we need to give here 2 more hand for this carbon. Similarly this carbon has 2 hands, so we need to give 2 more hand here. Okay, this carbon you see it has 4 hands, so 1 more hydrogen. Okay, so this carbon it has only 1 hand, so we need to give here 3 more hands. Okay, and this carbon it has how many hands? 1, 2, 3. So how many hands should be there? Only 1. Why 1? Because carbon should obey this tetravalency rule. It should have 4 hands. This carbon it has only 1 hand, so it should have 3 hands. This carbon 2 hands is present, so 2 more hands. This carbon only 1 hand is there, so 3 more hands. So I hope you have understood this structure. If you have not understood this structure, you can comment me in this comment section below. So let me clean the board now and give some more complex structure with multiple bonds. Suppose I have given here this structure. So in this case, you see the corners. This is one corner, this is another, this is another, this is another, this is another. In this case, along with the single bond, there is a presence of double bonds also. In this case, you see, you need to count the double bond as well. So in this case, this carbon has only 3 hands. So 1 more hand is required, isn't it? This carbon you see, it is fully full. That means no hand is required. Already 4 hand is present. Why? This is 1, 2, 3 and this is 4. So this carbon don't require any other hand because it is fulfilled with its own hand. So in this carbon, it should have only 1 hydrogen, only 1 hand because 3 already it is present. And this carbon, it has only 1 hand, so 3 more hands should be present. This carbon, 3 hand is present, 1, 2, 3. So only 1 hydrogen. This carbon, 2 hands are present, so 2 more hydrogen should be present here. Okay, so I hope you understood this structure as well. now you need to know the number of sigma and pi bond for N for a structure. So I am writing here, find the number of sigma and pi bond. Okay. So always remember that sigma bonds are formed at the first stage because sigma form is formed by the headwise overlap. So if you consider this is the orbital, these two are orbitals, so headwise overlapping is called sigma bond. So sigma bond is formed, then only the pi bonds are formed. How pi bonds are formed? Pi bonds are formed by the sidewise overlapping of orbitals. Okay. So in this case, again you can write the carbon as I have shown you like this, isn't it? So in this carbon you should have here 3 more hands. Here 3 is already present, 1 more hand. Here it is, 3 hands are present. How of 3? 1, 2, 3. So 1 more hand is required here. And in this case 3 hand is present as like this. So I will give here only 1 hand. In this case 2 hand is present. So I have given here 2 more hydrogen. Okay. So this is clear for you as I have already explained in this my previous topic. So in this case you see the number of single bond. Okay. So in this case with this carbon how many single bonds are there? Not double bond. In this carbon there is no double bond. So all are single bonds. That means all bonds are sigma bond. So for this carbon I will write here how many single bond? 4. 1, 2, 3, 4. Okay. So 4 for this particular portion. So in this case for this carbon, this hand already you have taken here 4. Okay. So from these and these 2 more sigma bonds are present. Why 2 more? Because here there is no multiple bond and here it is multiple bond. For multiple bond I have to write that is pi bond. Okay. So here 2 sigma bonds are present. So here 2 sigma. So it was 4 pi bond. Okay. And for this carbon I have already taken this portion. So this portion is so I will explain here this up to this there was 2 sigma bond and pi bond, 1 multiple bond was present and that multiple bond is pi bond. So 1 pi bond is present here. So next comes this portion. From this carbon we are going to consider here 1 bond with hydrogen and here it forms only 1 bond. So 1 plus 1, 2. 2 sigma bond is formed for this. 2 sigma bond. And number of pi bonds for this? No. Obviously no, this we have taken already. So for this we will consider this carbon. Okay. This carbon forms 1 bond with hydrogen, that is sigma. And here 2 bonds are there. Out of this 2 bond, 1 bond is sigma. Isn't it? So this sigma and this sigma. So for this carbon it has 2 sigma bond. And number of pi bond for this carbon? 1 pi bond. And for this carbon already we have taken this portion. So this portion we have 2 pi bond. Isn't it? 2 pi bond we have. And so the number of, so we can write here number of sigma bonds is equal to 4 plus 2 6 plus 2 8 8 plus 2 10 10 plus 2 12. So 12 number of sigma bond and the number of pi bonds is number of pi bonds equal to 2. So what you need to remember is that all the single bonds are sigma, okay, and the multiple bonds, when it is formed, then the one bond you have to consider that as sigma and other bond as pi bond. Okay, so for this there are number of sigma bond 12, number of pi bond is 2. So I hope you understood this. Let me consider one structure which has triple bond. So let me consider this structure. In this you can see there are 2 triple bond and 1 double bond. Okay. So similarly first we will just write all the carbons and we will arrange all the hydrogen with this. So this is the carbon. So this carbon. So tell me how many hydrogen should be present here? Only 1. Why? Because already it has 3 bonds. In this case already 4 hands are there. Why 4? 1, 2, 3, 4. You can see 4 hands are already present. For this carbon 2 hands are present, so 2 more hands should be present. In this case this carbon has 3 hands, so 1 more hydrogen should be present here. This carbon it has 3 hands, 1 more hydrogen should be present here. In this case it is fully loaded because it has 4 hands. In this carbon it has 3 hands, 1 more hydrogen should be present here. Okay. So now you see the number of sigma bonds. So this carbon forms with this hydrogen 1 sigma bond because this is a single bond. Okay. This carbon and this carbon it forms here 1 sigma bond and other 2 bonds are pi. Okay. So this carbon and this carbon here forms single bond, so it is sigma bond. This carbon and hydrogen it forms here 1 bond, so sigma, 1 bond sigma, 1 bond sigma, sigma. In this case there is 2 bonds, so only one is sigma and other one is pi bond. In this case carbon hydrogen forms only 1 single bond, so this should be sigma bond. This carbon and this carbon it forms sigma bond, and this carbon it is similar to this carbon, so it has 3 bonds, so one should be sigma and other are pi. And this carbon forms a bond with hydrogen, so it is also a single bond, so it is also a sigma bond. So I hope you understood this. So now let me count the number of sigma bond. Number of sigma bond equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. And number of pi bonds. 1, 2, 3, 4, 5. So I hope you have understood this particular structure and the number of sigma bond and number of pi bonds, how they are formed. So you need to remember what just the tetravalency for carbon, isn't it? So I hope you have understood this class. So if you have understood this class, please subscribe my channel for further good videos, and if you have any doubts in other topic as well, you can ask me in the comment section. I will try to solve all your problems. So keep watching. Thank you for watching. Bye.